Before we dive into inequalities with two variables, let's look at an inequality with one variable. Suppose 2x minus 3 is less than 5. Try plotting this inequality using the interactive graph. You can drag the dot, drag the line to make it point left or right, and press this button to switch between an open and closed dot. Once you've got the correct graph, click over here or click here to review. Great, so next let's look at an equation with two variables. 6y plus 7 equals 2x minus 5. Try solving this equation for y in terms of x. Once you've done that, we'll move on to inequalities with two variables. Nicely done. So you can subtract 7 from both sides and then divide both sides by 6. That gives you y equals 1/3 x minus 2. But what if, instead of an equation, we started with an inequality, where 6y plus 7 is greater than 2x minus 5? Well, you can perform the very same steps, subtracting 7 from both sides and then dividing both sides by 6, and you'll get that y is greater than 1/3 x minus 2. So solving inequalities with two variables is just like solving equations with two variables. So next, take a look at this inequality. 2y minus 5 is less than or equal to 6x plus 3. Try solving for y in terms of x. Y must be less than or equal to what? Nicely done. You added 5 to both sides and then divided by 2 and found that y is less than or equal to 3x plus 4. Now what do these inequalities actually mean? Well, just like with equations, only some values of x and y make this inequality true. For example, which of these values of x and y are solutions to this inequality? Well, let's look at the first one together. X equals 1 and y equals 4. Are these values a solution? When x equals 1 and y equals 4, is y less than or equal to 3x plus 4? To find out, let's plug in 1 for x and 4 for y. 3 times 1 is 3, and adding 4 gives us 7. So is 4 less than or equal to 7? Yes, so that means this is a solution for our original inequality. When x equals 1 and y equals 4, 2y minus 5 is less than or equal to 6x plus 3. Okay, so take a look at these other values for x and y. Which are solutions to the inequality? Nicely done. So these values for x and y represent another solution, and the same goes for these values. But when x equals 0 and y equals 7, y turns out to be greater than 3x plus 4, so this is not a solution. Now you might remember a special rule for inequalities involving negatives. To solve an inequality like this, negative 2y is greater than or equal to 8, you might divide both sides by negative 2. But whenever you multiply or divide an inequality by a negative number, you have to flip the sign. So this greater than or equal to becomes a less than or equal to. So we have y is less than or equal to 8 over negative 2, or negative 4. And this rule also applies to inequalities with more than one variable. Now earlier, you solved this inequality for y in terms of x, and here's what you got. But now, suppose the coefficient for y is no longer positive 2, but negative 2. So now, if you solve for y in terms of x, which of these inequalities do you get? And if you'd like to review this rule instead, click over here. Great, so you added 5 and then divided by negative 2. And when you divided by this negative, you remembered to flip the sign. So y is greater than or equal to negative 3x minus 4. So as your final challenge, can you identify which of these are solutions? Which values of x and y solve the inequalities up here? Before graphing any inequalities, try graphing this equation, y equals negative x plus 2. You can drag the line up and down to change the slope, and you can move the yellow dot to change the y-intercept. Once you've got the correct line, press the Submit button over here, or click here to review. Excellent! So here's the graph for the equation y equals negative x plus 2. So for every point on this line, its y-coordinate is equal to -1 times the x-coordinate plus 2. Now suppose instead of y equaling -x plus 2, we say y is greater than -x plus 2. Where on the graph are the solutions to this inequality? To get started, take a look at these 5 points. Which of these are solutions? For which of these points is y greater than -x plus 2? Exactly, so for these 2 points up here, y is greater than -x plus 2. And here are a few more points where y is greater than -x plus 2. You can double check every one of these. In fact, for every point in this shaded region here, y is greater than -x plus 2. So every point in the shaded region is a solution to the inequality. Now remember, the line includes all points where y equals -x plus 2. So the line itself is not part of the solution, and we can indicate that by making the line dashed. So above this dashed line, meaning in the positive y direction, that's where y is greater than -x plus 2. Now how could we draw the inequality y is greater than or equal to -x plus 2? Well, that's where y is greater than -x plus 2, so the shaded region, as well as where y equals -x plus 2. So we draw a solid line to indicate it's part of the solution. Next, what if we make this a less than or equal to symbol? Well, the solution no longer includes this region above the line. Instead, it's the region below the line in the negative y direction. And finally, if y is less than -x plus 2, then the line itself is no longer part of the solution, so we draw a dashed line again. So next, take a look at this solid line and shaded region. Which inequality is represented by this graph? Nicely done! So this is the graph for y is less than or equal to 3/2 x minus 3. This line is where y equals 3/2 x minus 3, and this shaded region is where y is less than 3/2 x minus 3. And here's the graph for y is greater than or equal to 3/2 x minus 3. And here's the graph for y is less than 3/2 x minus 3. For this inequality, the line is no longer part of the solution, so it's dashed. And finally, here's the graph for y is greater than 3/2 x minus 3. Now it's time for you to graph your own inequalities. First, try drawing the graph for y is greater than 2x minus 3. You can switch between a dashed and solid line by clicking this button here, and you can shade above or below the line by clicking this button. Once you've got your answer, press the Submit button over here and feel free to ask for a hint if you need one. Nicely done! Next, try drawing the graph for y is less than or equal to -1. Precisely, so these are all the points whose y-coordinates are less than or equal to -1. Makes sense, right? Okay, next, graph the inequality 3x plus 2y is greater than or equal to 6. And for this one, it might help to first rewrite this in slope-intercept form. Excellent! Okay, here's your final challenge. Try drawing an inequality where the points 4, 1 and 2, -2 are solutions, but 2, 3 and -1, -3 are not solutions. There's more than one correct graph you can draw, and it might be a good idea to mark off these coordinates using the pencil down here. Nicely done! So these were the 2 points you wanted to be part of the solution, 4, 1 and 2, -2. And these were the 2 points that were not part of the solution, 2, 3 and -1, -3. So here's one possible solution, and it happens to be the inequality y is less than 1.8x minus 3.3. But any line passing between these points like this, and where the region below the line is shaded, would have been a correct answer. Inequalities that include only certain points like this show up in the fields of artificial intelligence and machine learning. In particular, you'll see them when you study what are called support vector machines. It's a fancy name, but the idea is something you can appreciate now that you can draw inequalities. For example, suppose you have a computer program that you're training to tell the difference between images of dogs and images of cats. One way this program could work is to look at features of the two sets of images and graph those features on a coordinate plane. You might notice that all the dog images show up over here while the cat images are down here. Now, a support vector machine, or SVM for short, is a technique for figuring out the inequality where one group is included in the solution while the other group is not. So here's an example of a solution. And when this program looks at a new image, like this one down here, that is not a solution for the inequality, the program will be able to tell you that this is an image of a cat. Pretty cool, right?